All right, let's jump right in. You know that feeling when you're trying so hard to get more done, but everything just seems to get slower and slower? It's a total paradox, and it is super frustrating. Well, today, we're going to unpack the simple but incredibly powerful formula that explains exactly why this happens. It's called Little's Law. So, let me ask you this. When you're behind schedule and the pressure is on, what's your gut reaction? Is it to just start more things at once? To get more balls rolling? I mean, on the surface, it makes sense, doesn't it? But here's the crazy part. As Daniel Vacanti points out, that very instinct is the trap. This panic mode of just starting more and more work actually kicks off a vicious cycle. Everything takes longer to finish, which just adds more pressure, which then makes people want to start, you guessed it, even more work. It's a downward spiral. So, how do we break out of this cycle? How do we escape the trap? Well, it all starts with understanding a really elegant piece of math that governs how work flows through, well, pretty much any system. So let's pull back the curtain and introduce the law that explains it all. Okay, here it is. L equals lambda times W. This is Little's law, and it was proven way back in 1961 by an MIT professor named John Little. Now, don't let the Greek letters scare you. It's actually super straightforward. L is just the average number of things in a process. Lambda is the average rate that things arrive, and W is the average time a thing spends in that process. That's it. Simple, but as you'll see, incredibly profound. Now, depending on who you're talking to, you might hear different words for these same ideas. So, in the world of project management, L is called work in progress, or WIP. Lambda is often called throughput, which is basically how fast stuff gets finished. And W is known as cycle time or flow time. Don't get tripped up by the jargon. The names might change, but the underlying math, that relationship, is exactly the same. Okay, enough with the theory, right? Let's make this real. I've got a perfect, everyday example that's going to make this whole thing just click into place. So we're going to borrow a great example from one of the original papers on this. Let's head over to Caroline's house. She's a wine lover, and she's got a nice little collection going in her cellar. So, picture this. If you were to just peek into her cellar on any random day, you'd see about 160 bottles just hanging out. This is her average work in progress. That's our L. Now, Caroline also keeps pretty good track of her purchases. She knows that on average, she adds about 8 new bottles to her collection every single month. That is her arrival rate, our lambda. All right, so here's the million-dollar question. Without putting a little tag on every single bottle and tracking it for years, can we figure out how long a bottle typically sits in her cellar before it gets opened? Can we find her average cycle time, our W? And this is where the magic happens. Thanks to Little's law, the answer is absolutely. We just flip the formula around a bit. We take the average number of bottles, that's 160, and we divide it by the number she buys each month. That's 8. And what do we get? 20 months. Boom! On average, a bottle chills in her cellar for 20 months. And we figure that out without tracking a single one. That's the power we're talking about. Okay, so this is way bigger than just wine cellars, obviously. The really incredible thing about this law is that once you see it, you start to see the exact same dynamic playing out, well, everywhere. Just think about it for a second. A hospital maternity ward, the number of mothers is the WIP, births per day is the throughput, and the average length of stay is the cycle time. It's Little's law. Your email inbox, same deal. The number of unanswered emails is your WIP, how many you reply to per day is your throughput, and the average response time is the cycle time. It works for factories, loan departments, fast food lines, you name it. If there's a flow of work, Little's law applies.
So let's bring this all back home. This is all really interesting, but what does it tell us about solving that problem we started with? How do we actually use this to go faster?
All right, here it is, the big reveal. If you look back at the math, assuming your throughput, your team's general output, is more or less constant, there is only one lever you can pull to reduce the time it takes to get something done. Just one. You have to reduce the number of things you're working on at the same time. You must reduce your work in progress. I love how Daniel Vacanti puts it. It feels completely backwards, I know, but it is the absolute fundamental truth of how work flows. If you want to get more stuff done faster, you need to work on less. You have to focus, finish what you start before you pull in the next thing. Now, hold on. Before you run off and slash your to-do list in half, it's really important to know that Little's law isn't some magic spell. For the math to hold up, the system you're looking at has to play by a few basic rules. First off, the system has to be stable. Your work in progress can't be constantly exploding to infinity or shrinking down to zero. And here's the big one. On average, the rate that work comes in has to equal the rate that work goes out. And, pretty obviously, all the work that enters the system has to eventually leave. You can't have stuff getting stuck in there forever. And this is a really crucial point to get. Little's law is descriptive, it is not predictive. It is a mirror that perfectly describes the relationship between the averages in your system. It's not a crystal ball for forecasting the future. You can't just decide to double your WIP and expect your output to magically double. The law simply tells you that if one variable changes, the others must change to keep the equation in balance. So, I'll leave you with a question to chew on. Think about your own work, your team's projects, even just your personal to-do list. What is all the work in progress you're juggling right now? And based on what we've just learned, what do you honestly think would happen to the time it takes you to get things done if you made a real, conscious effort to reduce it? The answer might just be the key to finally getting things moving faster.